So the tools that we have right now is that we can find the distance between 2 points on the graph. We can use the distance formula, or we can draw it on the graph and use Pythagorean theorem. We can find the midpoint of a line, the actual location in between 2 points. We can also find another endpoint if what I know is the midpoint and an endpoint. We can do all those things right there. The last thing that we have here in the first part of Unit 6 is the distance between a line and a point. Okay, so the way that we're going to do that is we're actually going to be using the distance formula, but we have to find a second point. So let's jump right in this and let's figure out how we're going to go about doing this. First thing that we're going to do is we're going to take the equation that we have in this particular problem, y equals 2x minus 3, and we're going to graph that. Now, a couple things we got to remember. The slope of this line is 2. Okay, so we have 2 over 1 as the slope. Now, the y-intercept that we have in this case is negative 3. Okay, so when we go about graphing this, and we start off at the point negative 3, or on the y-axis, there's negative 3, and now we're going to run the slope of 2 over 1. So from here we go up 2, 1, 2, and over 1. And we can do that as many times as we want to. 1, 2, and over 1. Let's do it one more time. 1, 2, and over 1. Now from there we can actually connect our line. And we would hope that it'd be super straight. We're going to take that other point that we know right here of 3, negative 2, and we're going to plot that. So 1, 2, 3, 1, 2. And there's where the point 3, negative 2 exists right there. Now what we have to do is we've got to find another point. Okay, and the other point that we want to find here is actually going to be a point that is on this line right here. Okay, and once we know the point that is on the line, then we can use those 2 points in the distance formula and figure out the distance between this point and this line right here. All right, so here's what we're going to do. If the slope of the original equation was 2 over 1, what we need to do now is we need to find what the slope of the perpendicular to that is. So all we're going to do is we're going to take 2 over 1 and we're going to flip it over and make it 1 over 2. And also, because 2 over 1 was positive, we're going to make it negative. Okay, that's called opposite reciprocal. So flip over the slope and change the sign. So now we have a 1 over 2. So from here I'm going to go up 1 and over 2. So now you can see that I have found a point on the line here that I'm going to use distance formula. So what is the ordered pair for this point right here? Well, you're looking at that one, and now we see that that ordered pair is actually 1, negative 1. Now, between this point right here and that point right there, I'm going to use the distance formula to figure out what the distance is between this point and this line. So here we go. Now, the distance formula, again, as you recall, I'm going to subtract my x value. So in this case, it becomes 3 minus 1 squared, and then a plus sign. And then I'm going to subtract my y values, and in this case, that's negative 2. And it's actually plus 1 now because of this minus sign squared. So here's what we have. 3 minus 1 is 2 squared plus. Now, negative 2 plus 1 is actually negative 1. But when we square that, the answer will be positive. So we end up here doing the algebra to find that the value is actually the square root of 5. Well, how far is that? The square root of 5 feet away from you. That doesn't make much sense. So round that into decimal form, and we find out that it is approximately 2.2 units away. Okay, so both those answers are acceptable. And we got another problem that's very, very similar to it, but it's just one more chance for us to do it. The difference on this one right here is actually going to be that the slope here is going to be negative. All right, so we're going to have to get an opportunity to do some things a little bit differently. All right, first things first. Let's identify what is the slope from the original equation here. Now, my slope in this case, and again, where do you find slope? Slope is just the number that's in front of the x. Well, we find that in this case to be negative 3 over 2. And my y-intercept is 1, okay? So from that information right there, I can actually graph the original equation here. So we're going to start off with my y-intercept of 1, and the slope is negative 3 over 2. So we're going to go up 3, 1, 2, 3, and to the left 2, 1, 2, plot a point. Now from here I'll go down, 1, 2, 3, to the right 2, 1, 2. And that should be enough right there to go ahead and graph these. If you don't miss the points. There's a little bit better line for you. Okay. Now the second thing that we did is, again, I need to identify, or go ahead and plot this point right here. So when I plot that point, now I have 6, negative 1. Well, that exists 6 to the right and 1 down. So there's the point 6, negative 1. Now we're going to go back and I'm going to find the perpendicular slope right here. So remember, how do we find the perpendicular slope? I take this number and I flip it over, right? Because that's called reciprocal. And then I change the signs. I make it opposite. So this one was negative. Now it's positive. Okay? So from the point now, 6, negative 1, from the point 6, negative 1, I'm going to go 2 down. So I'm going to go 1, 2 down, and I'm going to go 3 over. 1, 2, 3. And there's my new point right there on the line. Now, what's the ordered pair for that point? We'll find that we have 1, 2, 3, 1, 2, 3. So we have the point 3, negative 3. And now we can use the distance formula again to figure out what is the distance now between the point and the line here. So in this case, again, subtract the x values. When I subtract the x values, I have 6 minus 3. And I'm going to square that, plus sign. Subtract these x values, and I have negative 1. And again, this actually turns into a plus 3. Why? Because of that negative sign. Carrying out the algebra now. 3 squared plus 2 squared. That gets me 9 plus 4. That gets me the square root of 13. And again, oftentimes when you're talking to somebody, you're not going to say, hey, how far apart are you guys? All right, we're the square root of 13 away from each other. You're probably going to round that to decimal form. And when you do round that to decimal form, we find out that the result is actually approximately 3.6. So there we go, in the end. Here's what we're going to do. We're going to graph the line that we have. Now, guys, unless the line is already given to you, then there's one thing that you don't have to do. Graph the line that's given to you, plot the point, run the perpendicular slope from the point to the line, and now I have 2 new points. From those 2 new points, I use the distance formula, which everybody ought to be good at by now. Find out the distance between a point and the line.